The breadth of our reach as humans has always placed us in the middle, between the infinitely large and the unimaginably small. With our unaided eyes, we could glimpse horizons and wonder what lay beyond. We could espy the smallest creatures and wonder how they perceived their world. So, we have used our powers of invention to extend our limited reach. From the earliest refracting telescopes, such as that used by Galileo to lay the foundations for observational astronomy, through William Herschel and his 40-foot reflecting telescope, to the 250-foot Lovell radio telescope at Jodrell Bank Observatory and the awe-inspiring Hubble Space Telescope, we have extended the reach of our knowledge to the farthest-flung regions of the universe. From the initial van Leeuwenhoek microscopic examinations of red blood cells and spermatozoa, through Henry Clifton Sorby's pioneering studies of the microscopic structure of iron and steel, to today's increasingly more powerful electron and tunneling microscopes, we have extended the reach of our knowledge to the most infinitesimal realms of the physical world. Our vision can now encompass the building blocks of living forms, as well as the fundamental structure of the elements, down to the atomic level. While the future beckons us to explore and inhabit realms at immense distances, our ability to embrace and feel at home in the minuscule worlds of the present bodes well for those future aspirations. Smaller is better, goes the saying. Less is more. This is no truer anywhere than it is in technology. Powder metallurgy is ideally suited to advance this concept. To be thriftier in the use of materials and in so doing help conserve energy resources. To make smaller components the equal of larger ones in performance, helping end products leave a smaller footprint on the environment. To enable innovative applications in the field of human health by achieving incredible complexity and precision in mass-produced miniature-scale parts. The winners in the 2016 PM Design Excellence Awards competition, sponsored by the Metal Powder Industries Federation, amply demonstrate these capabilities in their own ways. They focus on PM's strong points to gain and extend their competitive advantage, push production capabilities and process tolerances to their very limits, and bring originality to the conception of what is possible through creative design. Ladies and gentlemen, it gives us great pleasure to present to you the winners of this year's competition. 4 grand prizes and 10 awards of distinction have been given. We'll begin with the awards of distinction. The award of distinction in the automotive engine category has been given to Cloy's Gear and Products for 3 steel sprockets made for EVIS Engine Systems LP. The components, a rubberized crankshaft sprocket and 2 rubberized oil pump sprockets, a drive and a driven, go into a General Motors Generation 2 high-feature V6 engine, currently installed in the Cadillac CT6 and ATS, GMC Acadia, and Chevrolet Camaro. The crankshaft and oil pump drive sprockets are made of FC0208, while the driven sprocket is made of FL4405. The patented rubber design used on the crankshaft sprocket provides improved noise, vibration, and harshness, or NVH characteristics that exceed the engine manufacturer's demands. Fabrication via PM provides an estimated 30% savings over parts machined from steel bar or forgings. The annual production of 700,000 sprockets is projected to reach 2 million in 2018. An award of distinction in the automotive chassis category goes to Capstan for a drive pulley for an electronic power steering system. The iron-copper part goes into assemblies found in the Ford Focus and Escape vehicle platforms. This unique 6-level component with 5-degree helical pulley teeth has a 50-micron surface profile tolerance, which requires tight tool wear control. The part is formed net shape except for the inside diameter, threads, 1 bearing face, and 2 stamped flanges that are added using capacitive discharge welding, which allows for precise control of the gap between the flanges and the teeth. PM was chosen as the fabrication method because it offered far better precision than the die-cast alternative at a competitive price. Another award of distinction in the automotive chassis category has been won by GKN Sinter Metals for a copper steel-driven pulley for an electric power steering system made for next-tier automotive. The pulley is a complex net-shaped compacted part with a unique helical geometry, tight tolerances, and length-to-wall thickness ratios that push PM production capabilities to their very limits. Due to its 4 lower and 3 upper levels and the powder transfer requirements, the part is compacted on a CNC press with a rotating tooling assembly for the net forming of the helical teeth. The pulley is delivered as an assembly with a capacitive discharge welded flange. Close collaboration with the customer in the design of the part, which includes net-formed lightning holes, yielded savings of more than 10%. The award of distinction in the Lawn and Garden Off-Highway category was given to Indo-US Mimtech Private Limited, India, for a MIM 17.4 PH stainless steel diesel leak-off union made for Lamborghini, Italy. The part goes into the fuel injection of a line of Kohler diesel engines that are assembled in JCB midi and mini excavators, compact wheeled loaders, and teletruck forklifts. Custom ceramic setters are used in sintering to maintain the straightness of the 4 tube-like features and the pitch between 2 center tubes, so critical for assembly. The part is molded close to net shape, needing only a reaming operation to achieve straightness of the long hole. A conversion from a previously used plastic part, whose performance suffered in the tough working environment and load vibrations in the field, the MIM part delivered savings of around 10% through improved quality. The award of distinction in the Aerospace military category goes to Advanced Forming Technology, an ARC Group worldwide company, for a MIM 17.4 PH stainless steel ferrule that goes into an aerospace engine made by its customer, Rolls-Royce. The part provides a conductive path between the screen and the engine, while offering support to the single cable and preventing the placement of cable loading on the screen. Meticulous attention to mold design in order to optimize gate location and material flow enabled this complex geometry to be formed entirely using pass core shutoffs and slide action in the injection mold. The component is sintered exactly to net shape, with no secondary operations needed to meet required dimensional specifications. Cost savings were the primary driver for the switch to a MIM part from one machine from bar stock. The award of distinction in the hand tools recreation category has been given to Parmatech Corporation for a MIM 4605 low alloy steel trigger. The part goes into an adjustable trigger system on a pump-action shotgun. The extremely complex part geometry, which features multiple thickness changes and slots, required precise tooling to address sufficient machine stock for effective secondary operations. The part is sintered to near net shape, with secondary machining operations achieving the critical fit of the B datum hole, the threaded clocking hole, and the finger loop supports. The part design places the gate directly at the B datum hole position, so its remnants are effectively removed by the machining of the hole. A molded-in sacrificial bridge, which is also removed by machining, allows sufficient flow and support into both sides of the slotted finger loop. The MIM trigger delivers savings of around 50% over the machined version it replaced. An award of distinction in the electronic electrical category was earned by Indo-US Mimtech Private Limited, India, for 3 parts: a mirror cover, a base, and a middle, made for Optosense, Russia. Molded from MIM 316L stainless steel, the parts are assembled into an infrared gas sensor for methane and carbon dioxide detection that has extremely low power consumption. A new application designed specifically for the MIM process, these are medium complexity parts that have an aesthetic requirement on a few reflective surfaces. They are formed to net shape, then buffed on certain surfaces. The fabricator currently delivers parts for 150,000 sensors annually. Another award of distinction in the electronic electrical category goes to GKN Sinter Metals for an aluminum PM heatsink made for Visteon. The part is used in a high-volume global automotive stereo application. Due to the part design, with thickness variation ratios of 1, 2.1, and 11.3, deflection control is required to manage the extreme changes in length for the 3 levels. Its unique tower design provides optimized heat chimneys to remove heat from specific areas. The part is produced to net shape with no secondary machining operations needed. The high material ductility of the special aluminum PM alloy, combined with the precise positioning of the tooled-in assembly holes, enables assembly of the heatsink using the Tox joining technology, eliminating the need for attachment screws. The PM part displaced a die-cast one, offering higher thermal conductivity, 230 plus versus 80 watts per meter Kelvin. An award of distinction in the medical dental category goes to Flomet LLC, an ARC Group worldwide company, for a MIM tungsten electrode used in a surgical ablation device that uses high temperature for the removal of tissue. The use of tungsten enables the electrode to reach its operating effective temperature more efficiently and maintain it for a longer time than with other alloys. The part design, with its small geometry and minute features, includes a detail that allows it to nest into its mating components. It also adheres to a tight angle callout, a specification key to the product's function. Innovative tooling and advanced thermal processing techniques brought the component to its final geometry with only minimal secondary processing. The fabricator was able to achieve a wall thickness of 0.01 inch, multiple diameters of 0.025 inch within tolerance, as well as a flatness of 0.002 inch over a critical surface without secondary machining or coining operations. Another award of distinction in the medical dental category goes to Advanced Forming Technology, an ARC Group worldwide company, for a MIM wedge blank used in an endoscopic staple gun. Made from a MIM 440 stainless steel, the part has a complex and very small geometry that pushed the MIM process to the very limits of tolerance capabilities. It is produced by mounting 3 blanks on a coupon and then molding, debinding, and sintering them as a single part. The components are then finish machined in a wire EDM to yield 3 precision parts. This method makes possible the creation of very small and complex geometries with extremely accurate precision in mass quantities and at a competitive price. The part's 5 mm diameter size, less than half the previous low of 12 mm, enables new procedures to be created and enhances procedures in smaller patients, particularly in the area of pediatrics. There you have them, ladies and gentlemen, the winners of awards of distinction in the 2016 PM Design Excellence Awards competition. Please join with us in congratulating representatives of the winning companies as we invite them to come up to the stage to receive their awards.